Hi, David.
Morning, Rich. How are you?
Yeah, pretty good. How about yourself?
Pretty good. We'll give folks a couple of minutes to join us. Morning, Mark.
Good morning, and good morning, Rich.
Hey, good morning.
David, I like the way that from the OCP Global Summit that was just held recently, I like the way that all those videos are now available. I was just going through, in fact, listening to a video that included you introducing the CDX and then a person from Georgia Tech continuing on that.
Yes, thank you. Yeah, that's actually really cool that they did that, and I think I'm gonna start posting that video around for people who are interested about what we're doing. I think the way they've done it this year is really good.
Mm-hmm.
It also made us look a lot more professional, at least myself. That's good, actually. It's very good.
Uh-huh. I agree.
It gets, I guess, a little bit easier to organize things like that when the conference is large. And that's actually, it was kind of it was really like a movie production. The guys in the back were giving me signs, when to start talking, when to stop talking, right? When are they recording? When the audio was a little in the middle of the audio was a little bit off and hard to hear, they tuned it up. Then my beard was scratching on my mic, and it was that was very audible. So I had to stay and not move because. But yeah, and at that time they were giving me signs in the back, do this, do that. So yeah, there's a lot going on behind the camera. Hey, Russ.
Hello.
Mark, I think you can, if you could repeat what you just said about the conference, I think Russ will appreciate that.
Oh, I was just saying that I like the way that after the OCP Global Summit, it's easy to access the videos from all the presentations. It's nicely organized, the website. It enables me to kind of quickly jump to the presentations for topics I'm interested in. And I was just watching a video about CDX that David where David was introducing the topic, and then a speaker from Georgia Tech was continuing on that topic.
Well, that's good to hear. I'll
Yeah.
pass that on to Kevin. He actually does a lot of work to, we're literally in the conference, and he's actually working to start compiling all the videos and start the upload process. So he does a lot of effort towards that. So that's good to hear. Thank you.
Sure.
Yeah, and Russ, definitely the video production was top notch, and it made us look a lot more professional, right? With that video setup and the editing, I think it was great.
That's good.
Okay, so while we wait to get a quorum, Rich, I think this is your first time joining CDX.
It is.
What brings you to CDX? Is it my video or something else?
No, it was something else. I was at the Global Summit as well, and I
Okay.
talked to someone who described the CDXML, and I've been attending a different OCP work stream with the Chiplet economy, And one of the things that's relevant to that is chiplet interoperability. And
Yes.
so I took it upon myself to start experimenting with, well, first it started with an Excel spreadsheet, and then I turned it into a JSON file. And I wrote some Python to compare if each chiplet in a ecosystem, and I just came up with chiplet A, B, and C. And I had a XML file, I'm sorry, JSON file for each one with a subset of a full set of features
Yeah.
and things that are quantifiable, voltage
Yeah.
range, speed, these things, and came up with a way to, if you had a marketplace with a lot of chiplets, one of the things you would first want to do is be able to sort on which ones are compatible for let's say
Yes.
you've got. So anyways, yeah, it seemed relevant, similar to what was going on here, I think. So that's why I'm here.
Did I talk to you at the summit? I was talking to somebody about this.
I
I
think
think
it
it might have
was
been.
you. Yeah, I think.
Yeah.
Yeah, it was.
Yeah. Here's my. Okay.
Okay.
Good.
Yeah, I'll turn on my camera too. I got real bad backlight. It's terrible. Yeah.
Oh yeah. Okay. I remember. Yeah, we talked for a long time, didn't we?
Yeah.
Okay.
So
I think it's great that you're joining us. I think that's awesome. Um, how about this? When do you think you can present to us what your thinking is and see what we can do with your stuff? Right. So
yeah. What I did on the other work stream is I just shared the files. I zipped it up and I sent it to the gang, and some people installed it because they were capable of running the Python scripts themselves.
yeah.
I don't have like a set of slides that would be easier for me to go over, but I'm happy to do either. I'll be ready with slides next week, or I can just send you the zip with all of the files in it, and you can run it and experiment with it.
How about we do something in the middle? If you do you have an example JSON that you can share now, kind of go high level, just show us, and so that we can at least understand. Once we get the package, we kind of it will be easier to deal with. And the reason I'm asking this is CDX right, it has two pillars. One is data exchange formats, and the second is workflows. So I can see if you have some kind of a data format already, how we can incorporate that into CDXML and use that as a carrier, right? We don't necessarily produce tools, but workflow is another thing that we can take a look at. I think the overall topic of compatibility of chiplets is very, very interesting, and a lot of people and a lot of work streams are trying to tackle that. We've looked at it at very simplistically, at the very, very basic, at the electrical level. If two interfaces would be compatible, what do we need to define about interfaces electrically to make sure they're compatible? But there is a lot more behind the electrical interface that also would determine compatibility of chiplets, right? Such as link layer, protocol behind it, addressing, and so on. So that part we haven't looked at. So I'm really looking forward to seeing what your thinking was. So when you're ready, please go ahead and share that. Actually, today is the right timing. Today we were supposed to talk about SIPI kits, and our thinking about the electrical compatibility of chiplets falls in under the SI kit. So we can cover this topic today. We are not going to be able to make much progress anyway on the electrical definition, because I don't see the other folks that I don't see the other folks in the meeting. So we can discuss what you have when you're ready. Look at you on mute. I'm not sure if
No, yeah, I was on mute.
Yeah.
Yeah, it's gonna be easier to share my whole screen, so I'm just getting the
Okay.
things on screen that'll
Okay.
make it easy to talk about this. I'll be ready shortly.
All right.
I think I got everything. Okay. Where's the share thing? Okay, down here. Okay, so you should be able to see, yeah, several windows here.
Yep. It's coming up.
Okay, so can you see the text editor I've got here on the left?
Yes. Yes.
Yeah, so this is the JSON schema file. This is a subset. I picked UTIE as a way to test out and just kind of work through, my thought process. And I'm a hands-on guy. I like to actually. It doesn't take long to put together something like this. So, but it helped me think through a problem to actually work through something for real.
Mhm.
So I chose UCIE because the team I'm on with, and maybe I should start with a little background of what I'm currently involved with. Um, I'm primarily, I've been an analog ASIC designer for over 30 years. Um, and about a little over a year ago, I got hired with a small company that has a contract to the Navy through their Crane, Indiana, has a microelectronics research center. And they've got projects that are being funded by the Defense Department and the CHIPS Act, and they need a set of subject matter experts to make sure that the government is getting what they're paying for from the performers. And most of these projects have one commercial partner and one traditional defense company. And so anytime you've got two companies working together, there's always a chance that things aren't going to go well if they don't communicate. So we're also there to facilitate communication between the two teams. And so, anyways, that's what I'm currently doing. And I'm working on a team that's primarily focused on advanced packaging. So chiplet based projects are what we are helping to oversee. And of course, UCIE is an important part of that. So somebody on my team is doing uh, a deep dive on UCIE compatibility. And so it was a natural for me to start with UCIE. The
Mm.
work I'm doing with the OCP work stream is for chiplet interoperability. So beyond just the UCIE. So this is intended to be, a more encompassing approach. But for right now, it's primarily UCIE. And what I did is I came up with this schema. And here's an example file for vendor A. And you can see some things are Boolean, some are text, some have a range, some are numerical. And then vendor B and vendor C. And I purposely, had called some things that don't, are not compatible. Pardon me. And then I've got this Python file, which, I'm not sure if you read and speak Python, but it starts down here.
Yeah.
This is where main is, right? And there are some arguments that you can take at the command line. And so you've got, what your input directory is. And what it'll do is it'll go to a directory and recursively search through the directory tree, looking for JSON files. And then it makes a master list of all the files, and then compares them, performs a comparison operation, and then outputs to either or both a CSV file or an HTML. And on the screen here, this is the output of the HTML right here. So
Yeah.
pretty nice readable table. Something like this is appropriate for, handfuls of parts. And if you had, hundreds of parts, this might be too cumbersome. There might be some other way to display the information, but right now it's very suitable. And it, the identity is the diagonal, right? This is A versus A, but this
Yeah.
is A is compatible with B. A is not compatible with C. Now, it doesn't give you the details yet, but that would be a future enhancement where maybe
Yeah.
you could hover over this and you'd get, a short a list. If it's only a few things, you'd get a list of what they are. Otherwise, maybe you get a count, like 27 things are not, compatible. Please see
Yeah.
the full report, something along those lines.
Should you not
And
have,
then,
should,
go ahead.
should, should you not have a check mark on the identity diagonal?
That's a good question. I debated that. And I left it like this, as a, it's obvious that it should be compatible with itself.
Yeah, yeah. I'm just sorry. I'm just speaking. My bad. Ignore me.
No, it's all right. So then in here, this is the code, I've got all the functions collapsed just so we can read, what the function names are. It's not very complicated. It's actually very simple
Yeah.
right now. But
So
here's an
look,
example command line
yeah,
that you would run. And
yeah.
yeah, go ahead.
Uh, can you go back to the schema that you had? Can you explain how you define how you express a chiplet?
I'm sorry, I'm not sure I understood the question.
Yeah. But basically, what are these parameters which you specify for a chiplet and the different properties
Yeah, well,
around that?
so the way the XML file works, at least the way I've got it structured so that it's readable for me, the indent level, much like
Yeah.
Python, it indicates, who is, a sub to, some other higher level hierarchy, right? So maybe go through this, here's the title, UCIe chiplet specification, because this one is specifically for that. And I chose JSON after a cursory search and comparison of XML versus JSON. And I could be easily convinced to just go the XML route. But I chose JSON for reasons that I don't even fully remember anymore. It just sounded like it was appropriate for what I was trying to do. And I think one of them is you can have multiple JSON files. Like this would be the one specifically for UCIe, and it stands on its own. And the master JSON file would reference all these sub JSON files. And I'm not sure that that's true. I'm just trying to, dust the cobwebs off of my memory. I did this about 4 or 5 months ago. And but that would be my goal. So instead of having one long JSON file that's hundreds of pages long, have them divided by subject.
Yeah.
And then of course here's
Yeah.
the required
Yeah.
things you got to have. And go ahead.
Yeah, I was just going to make a comment in regards to JSON versus XML. Really, and in the end of the day, it's about the same thing as long as you're not expected to write it by hand. Right. The only difference in my view is whether you have to write it by hand or not. JSON is a little bit easier. And the other difference where JSON versus XML makes difference is if you have to transport it over a network connection. JSON tends to be a little bit more compact, parses a little bit faster, and that's about it. But in terms of storing library data locally, I also think they're about the same. So I personally don't have a preference. We just started with XML just for historical reasons. No other reason. Some people prefer YAML. YAML is also okay. They're all pretty much the same thing.
Yeah.
Yeah.
I agree. So, and I thought instead of doing more searching and comparing, I would just pick one and go with it and start using it. And if I ran into some
Exactly.
problem, I would not address it. And that's why I wanted to just focus on like one aspect of it to get started. First pass success, I'm happy with this. Next would be doing what I described, which is to have another JSON file for some other aspect of a chiplet. You know, maybe instead of communication, maybe I think that one of the important things is power requirements. You know,
Yeah.
so that could be another one that would be good to run through.
So your overall thinking here is you have a set of parameters which you kind of define. And then how do you determine compatibility? You just do a full set, basically full set match, or subset matches would also be okay?
You know, I really haven't gotten that far yet.
Okay.
I think that might need to be on a case by case, depending on what it is. In this one here, the one thing that I was looking to do was to accommodate, you know, these three data types that I think are going to be useful. And I'm approaching this problem from my experience. I said I'm an ASIC designer, but I also design a lot of circuit boards, and have for a long time. So, you know, my experience with circuit board design and going through, you know, it used to be, you know, data book. Now it's, you know, DigiKey catalog. And, you know,
Yeah.
reading all these data sheets and trying to compare all of the relevant parameters. I'm looking at this and you mentioned something that I think is potentially a good feature to have, would be some way to take somebody's published data sheet and then convert it to the JSON file.
Yeah.
Because there's a lot of parts and you know, thinking about a lot of common things. Let's say a voltage regulator, which is relevant in chiplets. You know, you're going to have a lot of very common specifications, you know, that are typical of a voltage regulator. So in that case, if you're auto generating, you might have to settle on you know, a subset. Some of the parameters might not be specified. You know, that doesn't mean failure. That just means more like a warning instead of an error. You know, like if you're going through your log, you know, that's more of a warning. And the tool could flag that and say, hey, this was not specified. So instead of a green check, maybe you get a blue circle. And the blue circle means we'll read the notes in the report or something. But what I did here with these, note that, you know, Boolean is a closed set. It's true or false. Everything else is enumerated. It's going to have to be in this list for it to be,
Yeah.
you know, and if it's not, then maybe that is the case where you get the blue circle. If it's outside of the list or it's empty, then you know, I don't call that a failure. I just call that you need to draw the human's attention to it. Um, and and the other thing, so when I presented this to the ecosystem Workstream, the discussion ended on acknowledging that this may not be a complete um, way to compare the chiplet interoperability. And the examples given were things that are more higher level architectural. And I admitted, yeah, well, you know, it doesn't have to be perfect to be useful. You can reduce a lot of the work that someone's doing and reduce the error proneness of comparing data sheets by hand manually. When you're doing it for building a board and you make a mistake, it's not that costly, really. You know, boards are quick turn and they're a lot less expensive than, you know, some expensive advanced packaging where, you
Right.
know, any mistake is really costly in time and money. So you need to have you know, ways to reduce you know, those errors that can happen. And automated checking is, you know, what really ASIC design lives and breathes on. So I think there is you know, a use for this, even if you
Yes.
get to the point of, well, it's a CPU and CPUs have instruction sets and maybe there at some case that they're not 100% compatible. And I think that's still acceptable. You know, and I'm more worried about, you know, the obvious physical interface stuff and not the software. That
Yes.
gets
Yes.
into,
Yes.
you know, it's too broad of a topic. It just, you know, the tree explodes and there's just too many leaf nodes for something like that. So, But yeah, there's my thoughts on the topic. This is where I'm at, and I'd like to help out in any way I can.
Yeah. No, this is great. This um uh definitely adds to what we have been talking about. Maybe why don't I share with you what we have been looking at?
Yeah. Okay, good idea.
Do you mind if I ask one question to Rich beforehand?
Yeah, please.
Yeah, thank you. Yeah, like David said, Rich, this looks nice. It looks helpful. But one thing I'm curious about is, isn't it true that a chiplet may have different interfaces, different logical interfaces, which may also have, it's possible, right, that it could have different physical properties for different interfaces. So, um, it seems to me that it may get to the point where instead of saying one chiplet is compatible with another, you're saying, well, this chiplet with that interface is compatible with this other chiplet and its interface, but not all interfaces of chiplet A are compatible with interfaces of chiplet B or something like that. Is that a situation that can come up, or am I sort of misunderstanding something?
No, no, I think yeah, that's a great question, relevant point. Absolutely can happen. That is something that, as I mentioned at the beginning when I introduced myself, we've got people on our team asking that same question. Um, and in the experience I've had in the past year, the projects that I'm looking at, there's usually, some main processor that's in an FPGA, and then you've got an A to D or a DAC or some other companion chips, and then memory, things like that. So the FPGA is the complicated one that really fits what you're describing. Um, a lot of these other chips, it's like the memory. What flavor HBM does it have? That's really the one question you would have to ask. And then, of course, drill down on, are there variants to HBM3 or HBM4 or wherever? And I don't know off the top of my head, but it quickly, you whittle down the possibilities with a memory chip. And same thing with these A to D chips and DACs. They typically only have one interface. So if you were going to be looking at something much more complicated, where you have more like, the general purpose chips like FPGAs, CPUs, and these things, yeah, they've got multiple interfaces. And I think you have to, then, settle for maybe what we would do is report the information, a different way. And maybe what you do is you pick your FPGA and then you find things that are compatible with that FPGA.
Yeah, I see.
Yeah. So, and I'm just, this is just me riffing up top of my head, but as a designer, that's probably how I would approach it. I'm gonna have something that's the design is based on, and then everything else would be, peripherals and accessories.
Yeah, I see. Okay, thank you.
Mhm.
Yeah. Let me give me a second. I wanted to open a couple of things. I'll be switching between those from time to time. Let me start with this. Okay. I think, yeah, I'm gonna keep switching windows, but so here is before I get to the um, interface definition and parameters and things like that, I wanted to give you an introduction to what is our baseline. So our assumption is the following. We have a chiplet defined, right, that has, so this is the chiplet, right? This is the demo design that we have been working on. And on this chiplet, what we already have defined is all the bump maps, all the pins and everything, right? So we already have a definition in CDXML that tells us this is a chiplet and here is the pins that it has, right? And here's the associated nets with that, right? So when we look at compatibility, then we are working at this level. I'm going to switch windows again, if you're wondering what I'm doing, and that is, okay, we have this chiplet here, right? Basically, the system of chiplets that we want to figure out if we can build, right? So each individual piece of these chiplets is already defines the pins, the bumps, the nets, and so on, right? So now we're looking at the next level definition. How do we do that? What do we need to define? And there is multiple components, at least in my view, to define chiplet compatibility. One thing is this is where we get into the SIPI kit, which is this window, right? So as Mark was suggesting, the way we thought about this, we are going to add this definition on a per interface basis, right? So of all that collection of bumps and pins, right, of all of that connection, we are going to take a subset of those, and we are going to say these pins are an interface. And then we go on to defining what that interface is, right? And this is work in progress, so it's a little bit messy. Don't mind the dust. But basically, right, when we look at interface, we want to be able to tell what is it, right? Is it serial? Is it what data rate? What encodings it has? And then identify the pins with that, right? How it's clocked, which are the clock pins. Right, and then, so this is at the high level, right? I think this will begin to kind of match to your definition, right? Whether this is UCIe and what data rate is running, right? Or whether this is PCIe SerDes, or if it's BOW, or if it's HBM interface, anything like that, right? We can begin to describe for this. Then we get into the electricals, start defining what is the skews, words, right? Different skews, jitter, and so on, right? The thinking was like this, right? Okay, we have an interface that say does UCE, and these two UCE seem to be compatible, right? When you look at say they support, they fit within the whatever the standard is defining as parameters for that UCE. But there is this aspect of, does that right? Okay, if I have two UCE compatibles, does that automatically mean that if I put two chiplets somewhere on my package, they will work? And the answer is not in the general case, right? We need to consider what the actual package is and the physicalities of the bump map, meaning, right, you may have same interfaces. If the bump maps are slightly different, maybe they're not routable on the package technology, or maybe just whatever the placement that you need is just too far for this to work, right? So what is needed for that, right, at this level, the chiplet itself doesn't know what the package is going to be, right? It cannot know that, but it needs to provide information, enough information, such that when I'm working at the package level, I can start planning my package, right? Run simulations and see, okay, would this link, would this routing between these two chiplets work or not, right? So we are looking to provide enough information for that to kind of make sure that that works. And really, right, that you can see it talks about equalization. It has talks about all these things, right? And even there is a little bit on the optical side that talks about linear drivers, modulation, and so on, right? So here we try to describe the interface by itself, and really in a way that I can then look outside of that interface, would that link actually work or not, right? Maybe I need to choose materials, packaging technology, placement, all of that stuff comes into play. The one thing that we don't have, and I really like, is the next level protocol on top of this, right? And I think there is two steps to get. There is one step to get to the protocol, right? Before we get to the protocol, and that is, what is the link layer looking between the two interfaces, right? Would that link layer be compatible or not, right? And then start looking at next level protocol, and maybe even, right, for example, say you have two chiplets, two UCAs which implement a raw protocol only, right? Does that make them immediately compatible? Probably not, because behind that raw protocol, right, whatever protocol sits on top of that interface protocol, that protocol needs to be compatible as well. Right, one side could be speaking AXI, the other one could be speaking AMBER, and nothing's going to happen. Right, even if electrically they work, link layer they work, UCA protocol they work, the next level protocol is not going to be compatible. And this is where we have a gap that we are kind of trying to figure out, how do we really address that? What are your thoughts on that topic? Or are we trying to bite too much with this?
Well, so one of the things that comes to mind is, my approach with what I started with was a simple tool that could be, used to just to weed out the obvious, it's not compatible, it's not going to work, don't waste your time on it.
Right.
The ones that are, the green check mark, that was the other extreme. You want to be, I think, very careful to hand out a green check mark. It's got to be identical, compatible, no doubts about it. And how do you judge that? Well, I think we're working on it. I think a lot of things are going to be in the middle ground, where the the blue circle I mentioned, which I just came up with on this call, that was just top of my head, right?
Yeah.
Let's mark it with something else that says, what we've done is necessary but not sufficient to guarantee interoperability. And then it's up to some other way to look at it. Because once you get up higher in that layer stack, like with a communication protocol, yeah, absolutely. There's some subtleties that might not be easy to quantify in a tool like what I've got, which is pretty straightforward and very simple. Let me add, what you've shown is really the next step of sophistication.
Yeah.
And and it's got more physical information, the actual, like, where the balls are, and like you said, can they be mapped together? And I think that it's getting similar to where the larger, like, let me just kind of use it as an example. When you plug an Ethernet cable into a switch or a hub, you expect that the pin order is going to work. You don't have to come up with something to switch the pins around. You know, so you've got these standardized interfaces. And earlier, late last year, early this year, there was a NOFO 2 put out by the Department of Commerce from NIST. They were fund a bunch of projects, and one of the topics was these standardized interfaces and connectors. Um, and yeah, I think that in order to have things that are just going to be compatible, you're going to have to commonize, agree on a certain pin order on certain things, these interfaces. Or you derate what they're capable of, what the speed is. If you had to
Yeah.
swap all the wires around, it's going to affect the speed you can reach, and it's going to be the limiting
Yeah.
factor. But at the level where I'm working with my very simple tool, that wouldn't be something that I would want to try to achieve, uh, other than maybe providing a note. Hey, you should look at this. You know,
Mm.
but yeah, 'cause you can't predict what is going to be useful and good enough, and in certain instances. And in where we're at now, my opinion, I'll share. Where we're at now with a lot of chiplet stuff is it's very, we're right at the beginning. Um,
Yeah.
I'm thinking more in terms of it's a mature ecosystem. There are parts that have been in that catalog for years and they're now legacy parts. They're still useful because they're cheap, and we've gotten the marketplace, we've got the processing, we've got the tool sets down to the point where one of the goals of the NOFO 2 in 5 to 10 years, they wanted to make it such that a 10-person team could put out a, and I don't remember the level of sophistication they described, but a 10-person team could put out a chiplet module in 10 months, less than $10 million. And it was the 10-10-10 goal. And, kind of mark, it's okay. It's nice to say 10-10-10 because it's clever, but really, once we get to that point, these are the things that I'm kind of thinking of, to where you've got legacy parts and you still, things are cheap enough that we're actually
Yeah.
doing it. Right now, everything's so damn expensive. Everybody's just scrutinizing everything that goes into its system, you know. Um, and so we're not really there yet
Yeah.
where, I'm thinking, my mind truly is in the future. Um,
Yeah.
right now, I think, we're building it from scratch, so you got to be careful. But I think learning lessons from things that are already out there, like
Yeah.
standardized interfaces. That's the only way we're going to get things down cheap enough. If everybody's got a custom pin order, it's just never going to work. Uh, just my 2 cents.
Yeah.
The other things
Yeah.
that you've got on here are very easy to say, yeah, it's compatible or not. We don't have
Yeah.
equalization. Okay, then that's going to limit your speed. Something to that effect. Um, they're quantifiable.
Yeah. Yeah. I agree. Right. In theory, a standard interface is gonna open up this, but the evidence, if I can read it that way, from the UCA consortium is it's hard to standardize it. Right? They had UCA 1.0, which was, hey, here's this one interface and it's going to solve your problems. And then if you look at UCA 3, they have different sizes now, different bump pitches, different pin ordering. And they try to figure out, right, even for different configurations, say they would allow you to connect a 32-bit UCE to 64-bit UCE. They define that. Right, they define if you want to connect a 32-bit UCE, a 25 micron pitch to a 32-bit UCE on a bigger pitch, right? How do you do that, right? They thought about that as well. I think the only thing they could come up as a standardization was the width of the interface kind of remains the same. You jiggle you move around the bumps and the pins and everything just to maintain that interface width, which is not bad. I think that's great, right? One thing we don't have to worry about is the width. It's just my 2 cents on that. I think one thing, if we want to take this to the next level, I think what we should think about is, okay, we have all these parameters defined. but we also need a compatibility matrix, right? In the sense that, hey, for example, if you look at the data rate, or actually not data rate, width of UCE, right? Technically, by 64-bit is compatible with 32-bit. Yeah, you're going to lose half of the bit, right, in that, but you can communicate over that. Just you're going to be communicating the 32 bits. And then the question is, does the other side support that? Does the 64-bit, although theoretically you could, the question is, did they implement that support? Maybe they didn't bother, right? So apart from defining, hey, here's the width of this interface and here's the possible values, well, they need to think about what does it compatibility, what does it mean in terms of compatibility? Say, the example you give for equalization, the fact that one doesn't support it doesn't immediately mean that it's needed and that it will work at lower speed. Maybe it can still work at the higher speed if the way these are connected together on the package is, if the link is good enough that you don't need the equalization, and you can actually turn it off at, on the driver side, for example, right, and save power.
Yeah, yeah. Let me this reminds me, there's an analogy here that I think potentially could be helpful. And that is, a lot of the some of the systems I've designed, I've learned ways to use parts that are available beyond what the original intention was. And for
Right.
example, you know, um, I use a lot of small little 8-pin microcontrollers, and you don't have that much I/O. Um, but I've got code base, built for a lot of small stuff, and then sometimes you need to expand your I/O, and using like a SPI port, SPI, or
Yeah.
just even banging, you can use a shift register, a parallel serial in, parallel out shift register as a port expander. Even though it's never been named that in any data sheet, you can do that. And shift registers were never meant to be compatible with a SPI port, but they were. So,
Yeah.
those are the compromises that get worked out over time with, clever, designers who realize something and they use something not what it was intended for, but it's very useful. And I think you're describing something very similar. And I think the people that would be interested in, doing something like have a 64-bit interface that is compatible with a 32 would be somebody like on the FPGA or the CPU side, to where their intention is to capture as much of a customer market as possible by being very flexible, so that anybody or many different applications can use their parts. So they put in a lot of Swiss Army knife kind of. That's what I call their pads. A lot of the pads on FPGAs are like a Swiss Army knife. They do everything. Um,
Yeah.
And that allows them to, enjoy capturing a lot of different customers, where the people making some of the other parts, like either an A to D or a DAC, or some sort of a machine learning accelerator, they don't necessarily have to be as flexible. And I think that is, relevant in the, a lot of this stuff can be useful, even if you're not, and like you described, turn off the equalization. Yeah, you're not going to get the speed, but still you can plug these two parts together and
That's
it
right.
worked for you. Mhm.
Yeah. Yeah, my overall view was that really the end customer, right, and the cost of that would decide whether something should be done, right? The question is, could it be done, right? Meaning it doesn't have to be super smart, like connecting. Technically, you can connect by 64 to by 16. Is it smart? Probably not. It's probably stupid, but hey, if the end product is something that the customer wants and they're willing to pay the premium, right? That's not, I don't see why I should put that restriction in a format or in any check, right?
Yeah. And there's other examples of, um, things that are done, like you said, doesn't necessarily, it's not the smartest thing to do, but you do it. And that is, in a lot of, uh, legacy designs related to, usually aerospace related stuff, to where the,
Yeah,
the qualification cycle is so expensive, you don't want to have to spec a new part if you can help it. And
that's right. Yeah,
we've been enjoying this progress on technology for a long time, but a lot of these older designs are stuck with you know parts from the 20th century, for crying out loud, and the
yeah,
packages are huge. And so there's been a lot of efforts in the past decade to harvest the die from these bigger packages and repackage them in something smaller, more modern. And that could be useful in the future, when we've got this chiplet ecosystem and there's a lot of legacy parts around, to where some parts might only be have a UCIe standard package interface, and
yeah,
yet a lot of the new parts that you want to use are in advanced package, and so you end up having a advanced package UCI interface talking to a standard package. And yeah, it doesn't make a whole lot of sense from just looking at the raw numbers, but there may be some higher level motivation, be it
exactly.
like I tried with these legacy aerospace designs, or some other reason that may be, yep,
Yeah,
that's what we're going to do. It could happen. Um, so yeah, I think
yeah,
just saying if it's interoperable or not is not an easy thing to do. There's a lot of ins and outs.
yeah. But I do like your approach. I think uh, in the SIPI kit, we definitely went deeper into that. I like your approach, and I think definitely we should split this into the interface definition into the basics. All right, basically have a basic definition that determines first level compatibility, and then next level details that may be required for analysis, for actual analysis, to determine if you can truly these two will truly electrically work, and then look at the protocol stuff.
Okay, yeah, I agree. Now, one thing that has come to my attention, and it's going to be one of those next steps thing. There is a standard from JEDEC called JEP 30.
Yep.
And yeah, it uses an XML schema for package and part models. And, there are probably some lessons learned that are in there that, that could be useful, when we're working on this. And I think I have that spec now, and
Yeah.
I'm going to go through it and see if there's anything in there that would be useful for like what we're discussing.
So, in regards to that, there's actually MOU between OCP and JEDEC. Actually, CDXML feeds into JEP30.
Oh, interesting. Oh, that's really
Yeah, I
okay.
just I just spent this morning 2 hours talking to JEDEC about some of the properties and things like that. So we the way it works is we develop stuff on our own here, right? Whatever we think is necessary, and then we feed those learning and requirements into JEP30, and that gets added. So if you take a look at the latest JEP30, it's going to have material design kit, it's going to have assembly design kit. That's all part of 3DK. The bump up definitions were enhanced a lot based off of the information we were working with, right? Because JEDEC JEP30 was basically PCB level definition, right? Parts at the PCB level, what such that you can express parts like that. And since we were working on chiplets, we kind of decided to collaborate on that. So we develop and feed into JEP30. They also have their own development phase. They get requirements from others, but at the end of the day, they merge in a way they merge CDXML data into JEP30. It doesn't have to be necessarily the same tags. The one thing we ensure is that same data is represented so that if I have CDXML data, I can port it to JEP30. Right.
Well,
So
that's
yeah,
interesting.
and I think not I think future things we do, SIPI kit, package DRM rules, stuff like that, that will also get added to JEP30. So we have a path. The reason I'm saying that is we do have a path to influence JEP30 through our work, basically.
Well, excellent. Yeah, that's really
Right.
good. Because
Yeah.
that helps everybody.
Yes. And I do like
Okay.
JEDEC, right? It's this organization. They work with other organizations as well. Something we just don't have the capacity to do. But one example would be they work with IEC, and IEC defines units. Basically, they have explicit definition of how units should be represented. All right, so you cannot have kilowatt with capital K, capital W, or somebody else comes in and makes it lowercase k and capital W, right? They have strict definitions saying, okay, if you're expressing power, this is the exact way to represent it. And there were some hairy definitions, but yeah, so they own that, but they are, JEDEC is working with them to make JEP30 compliant with that, to the level where IEC opens up their API and you can validate whether a certain unit is valid or not. So it's really cool.
Yeah. Yeah, I like it.
Yeah,
You know, I'm happy to comply just as long as it's defined somewhere.
yeah.
Okay. So is there like a Google Drive where this stuff is so I can see the CDXML schema? I'd like to
Yeah.
read through it.
Yeah, so the schema, so this is the entire, let me post a link in the chat window for the entire Google Drive that we have. Where is the chat window? Okay, here it is.
Okay, yeah, got it.
But yeah, if you specifically are looking for schema, schema is on the GitHub repository of OCP. Let's see. CDXML. Yep, this takes us to, this is, I guess this is the CDXML GitHub repo. So there's a couple of schemas in here: basic CDXML, material design kit, test design kit, assembly design kit. And there's a description for those here in the database. If you search for, actually there was a quicker way to search for this. Okay, I think, let's see, I knew of a clever way to do this, but anyway, let's see, test design kit. This should, yeah, this will bring you, there's basically two pieces to this. One is the GitHub repo, and the other one is the white paper that goes with it, that describes what's in it. Yeah, test design kit, material design kit, assembly design kit, and the white papers. So if you search for that on the OCP database, contribution database, you'll find that.
Okay, yeah, I did. I'm there now. Thank you.
Okay. Yeah. All right, we are at the top of the hour. Rich, thank you very much for joining us today. Hope to see you next time. Next week we are gonna. So the way we do it is we bi-weekly we talk about SIPI, and bi-weekly we talk about test design kit. So next week is test design kit. So we'll see you folks next week for test design kit discussion.
Okay, yeah, great. I'll be here. Thanks.
All right. All right,
Have a
everyone.
good rest of your day.
Yeah, thank you very much. You too.
Thank you.
Bye.
Hmm. Okay. Let's see. Oh boy.